On this episode, the sort of equipment you might need to test the performance of a bioretention system. Hey everyone, and welcome back to Ideanthro. You might be surprised to know just how regularly I have people come up to me and say, hey Jack, can you give me some advice or point me in the right direction for how to sample and how to test the treatment efficacy of stormwater treatment systems like bioretention systems. Now at some point in the future, I'm going to do a more detailed video about that. But today, I happen to be out at this system. You see this grassed bioretention system behind me. That was tested like 6 or 7 years ago, like around 2010-ish, maybe a little before, by Nathaniel Parker for his master's work. And because it was tested all those years ago, the testing and the sampling equipment is still set up. And I want to just take a moment to show you what that looks like. It's really important because often people come up to me like, hey, look, can I just take some grab samples of these systems and get an idea of how much pollution they're removing? And the answer is no, because that doesn't just do the trick. I'm not going to go into the details of that today, but what I will show you is the sort of setup that's necessary if you are going to sample one of these systems properly and robustly. So I'm going to spin this around and we'll take a look. So things that we've got here, first up here, is we've got a mount for a solar panel, and it also looks like we've got a rain gauge up there and maybe some kind of transmitter mounted on a metal pole. We've also got this sampling cabinet here, stores some equipment, and then on the inlet down here, we've got this arrangement. So we'll just zoom in for a second. Right behind here, you can see, just in there, we've got the old head wall. It's really tough to see, but it is in there. We've got the head wall, and for the sampling, they've installed this setup over the front of it. And why this is important is if you just take a grab sample from a bioretention system, you'll get an idea at that point in time just how much pollution was in that water. You'll get a concentration. But we know that storm events change over time. We know that a storm event might start off small and maybe it has more pollution in it by concentration at the beginning, and then you get more rain as it ramps up, you get more runoff happening, then maybe it tails off at the end, that typical kind of bell-shaped hydrograph that you might see. And so we need an idea of what's happening across the entire storm if we're going to accurately sample the performance of these systems. So this box setup that you're seeing on the front here of this system is a way to do that. Because if I just uncover this, that's built up rather robustly over time. The point here, so this would have once been freer than this. The point here is that we have a V-notch weir, and you've got an area storing water behind it. So you've got the ability to, at regular intervals throughout the rainfall event, to take samples out of there, but also to measure the depth of water going over the weir. And that can be used to calculate how much water is flowing out at any point in time. So if you then do that multiple times, so say if your storm or your runoff event lasts for like 60 minutes, if you do that regularly throughout the storm event, I'll spin this back around. If you do that regularly throughout the storm event, then what happens is you can take the flow rates at all those points and the concentrations at each of those points, and you can graph it and you can get an idea of the total volume of water in the whole storm and the total volume of the pollutants, and suddenly you can start talking about load reductions out of systems. If you then combine that, well obviously this is the inlet we've been looking at, with a similar setup in the outlet, and then you've got your load reductions. I just wanted to show that to you to give you an indication of the sort of sampling setup you might need to properly assess the treatment performance of a bioretention system. A big one like this. There are other ways for small systems, like manual dosing, like bringing synthetic stormwater to site. But for a system like this, robustly using real rainfall, this is the sort of setup that people have used in the past and you might need to establish. As I said, we will more detailed episode in the future, but I hope you find that interesting, and we'll see you next time.